We are going to continue our study of solving one-step equations. Today we're going to move on to multiplication and division. Remember that these are inverse operations. They undo each other. So if something originally shows multiplication, you can use division to undo that. All right, let's look at some examples. The first two that I have are multiplication. Actually, I can probably do, yeah, we'll leave it like that. That's fine. Okay, so we're going to run through our steps. We like to visually split it so that we know what is on each side. What am I looking for? Well, I'm trying to find x. What's attached to x on that same side? The 4. How are they attached? I don't see a symbol, so this is really multiplication. 4x is 4 times x. So to get rid of that, I'm going to divide. You'll see a lot of times we use the fraction bar, which is also a division symbol, but you could use the regular dot line dot or a slash, whatever you're comfortable with. Of course, what we do to one side, we do to the other. Now, when we talked the other day about the addition and subtraction equations, we were trying to get that thing to go to 0. Well, now with multiplication and division, we're trying to get the thing to go to 1. And if you have the fraction 4 over 4, that equals 1. So a lot of times we just slash through it. We get 1x, which is exactly what we're looking for. And then on the other side, I'll calculate. 20 divided by 4 is 5. So I think x equals 5. I always encourage you to check your solution. See if it actually works. Make sure there were no miscalculations. Make sure there were no missteps along the way. Even if you're not going to write it out, take the moment and say 5 times 4, right? We'll replace the x with the 5 and do 5 times 4. Does that equal 20 on the other side? Yes, we're good. It will come in super handy for division, and it will come in super handy with the negatives, which happens to be in number 2. We'll split it. What am I looking for? Y. What's attached? -8, right? We take that sign with it. How are these attached? What's holding them together? Multiplication. How do I undo multiplication? We divide. I want to take that sign. It's not just an 8, it's a -8. And we'll do the same thing over here. So we have 8 and 8, which gives me 1. I have 2 negative signs with division. That's a positive, which is exactly what I want. I want just plain y. If I hadn't put that negative sign there, the original negative would stick, and then I'd have a negative y, which is not at all what I want. When you divide by the same number, it allows you to cancel. All right, calculate over here. 24 divided by 8 is 3. We have a single sign, so I think my answer is y equals -3. Now, you might get the correct digit, but the sign is really where this check step is going to be helpful, okay? So I'm going to do -8 times -3. If you want to write it out, you certainly can, right? -8 times -3. Well, 8 times 3 is 24. We're good there. And I have 2 signs, odd even rule, finger trick, whatever you want. That gives me the positive 24 on the other side. So we're good. Had I forgotten my sign, what if I said this was just 8 times 3? I still would get the 24, but the sign would not be correct. And the sign really does make a difference. All right, so our answer here is y equals -3. So those are some multiplication examples. Doesn't matter where the variable is on which side, you're going to do the inverse operation, which is division. Okay, now here I've given you the traditional dot line dot symbol. So this says a divided by -4 is -9. What am I looking for? What's attached? How is it attached? How do I undo it? Okay, so I'm looking for a. The -4 is attached by division. I'll undo it by multiplying. Again, take that sign. You can use an X, you can use a dot, whatever. Okay, now over here, it's not going to be 16. That's a very common mistake. Yes, I'm multiplying by -4, but I originally divided by -4. So this actually goes to 1, exactly what I was looking for. So we're left with a. And over here, I'm multiplying. I don't like that X. That messes with my head. Sorry, I'll change it to a star. So now I'm multiplying. 9 times 4 is 36. I've got 2 negatives. So I think my answer is a positive 36. Now let's check. If I do 36 divided by negative 4, do I get negative 9? Well, the digits work. 36 divided by 4 is 9. On this side, there's a single negative, which means on this side, there should be a single negative. So we're good. Our answer is, in fact, A equals 36. All right, let's move to our last example. This is really a division sign. A lot of kids get confused when they're first learning this because they've really only experienced it as a fraction bar. Well, isn't a fraction sort of like a division problem, right? You take your pizza, you split it into fourths, you're really dividing. Fourth is a fraction, but it can also be represented with division. So what am I looking for? What's attached? How is it attached? How do I undo? I'm looking for y. Negative 3 is attached by division. I'll undo that by multiplication. Gotta change it to a star, sorry. Again, a lot of times students will think that this is 3 times 3. It's not. It's really negative 3 over 1 times what would be 1 over 3. So you end up with a positive 1. They cancel out. That's the shortcut. I'm left with y. And over here, I'm going to get positive 27. 9 times 3 is 27. There's 2 negative signs, so it's a positive. All right, so I will check that and say 27 divided by negative 3. Is that negative 9? Yes, because 27 divided by 3 is 9. There's a single sign and a single sign. This problem right here will make you a believer in the check step, because students so often will say, oh, it's division. Oh, I've got 3 and 9. My answer must be 3. It's not. Okay? If you make that mistake, and don't feel bad if you do, I've made it myself. If you make that mistake and then do the check step, you'll catch it and you'll be able to fix it.